Hello everyone, welcome to Lessons with Philip. And our class today will be on conversion from other bases to base 10. Now we have two questions on the board. Follow me as we solve it together, all right? Now we have to convert 0.415 to denary. Don't forget I've said denary or decimal are known as base 10. Don't forget in my last class I said base 10 we have some names to base 8, to base 2, base 10, base 12, and base 16. Base 2 is known as binary. It's known as binary. It's known as what we call bicimal. Okay? Base 8 is known as octa. Octa base. Then base 10 is known as denary or decimal. Okay? And base 12 is known as duodecimal. Okay? It's known as duodecimal. And this base 16 is known as hexadecimal. Alright? Don't forget this. There's a special name to all these bases. Base 2, base... We have some other bases like base 17, base 18, base 4, base 1. But those ones does not have a special name. This one's has a unique name, a special name. Alright? Now let's focus on our examples. We have to convert 0 point. Number 1, solution. Solution we have to convert 0.415 to base 6 to base 10 rather. We have to convert these to base 10. If you observe, none of the digits is greater than the base. The highest digit is 5 when the base is 6. Okay? Take note, please. Right? So what we are going to do is, in our previous example, we said if you have to convert 42, for example, this is a whole number. This is a decimal number. If you have to convert this whole number, we start from the rear. This will be given base 0, base 1, and so forth and so on and so forth. But in this case, the numbers, there is whole number, will be attributed 0. If there are more numbers, it will be going like that, 1, 2, 3, 4. Why the numbers after the decimal will be given minus. So this will be given minus 1, this will be given minus 2, this will be given minus 3. All right? That is how it goes. Okay? If you understand that, then you can proceed. So this will now be equivalent to, start from 0. That will be 0 times the base. 0 times 6, which is the base, raised to power 0. Okay? Plus, we have our 4. That will be 4 times, what is our base? Base 6. And what is our power? Minus 1. All right? Plus, all right? We have our 1. That will be 1 times, what is our base? Base 6. And what is our power? Power minus 2. All right? And the last one is 5 plus 5 times, what is our base? Base 6. Power minus 3. All right? Okay? Now the next thing is to open the bracket. 6 raised to power 0 is what? Is 1. 1 times 0 is 0. Plus 4 times. Don't forget in mathematics, I've told us in indices that when we have minus as power, when you remove the minus, it becomes 1 over. Let me explain. 6 raised to power minus 1. If I remove this minus, it becomes 1 over. I just introduced 1 over to what is left. So 1 over 6 raised to power 1. And 6 raised to power 1 is what? Is 6. So I will have 1 divided by 6. Alright? Plus 1 times 6 raised to power minus 2. That will be 1 divided by 6 squared. Okay? And 6 squared is what? 36. Okay? That will now be 36. Do you get it? Plus. Then 5 times. If I remove this minus, it becomes 1 over 6 raised to power 3. And 6 raised to power 3, you can use your calculator. 6 raised to power 3 will give us 216. That is 216. All right. So the next thing is to open the brackets. All right. This will now be 4, 0 plus 4 over 6 plus 1 times this will give me 1 over 36. Okay. Plus 5 times this will give me 5 over 36. All right. Now in this case, 5 over 216 rather. 5 over 216. In this case, you can decide to take your LCM. Your LCM, or you can decide to add them the way you want to. So the LCM is 216. Okay? 6 in 216. How many 6 can you find in 216? That will be 36. 36 times 4. 36 times 4 will give us 144. So we have 144 plus 36 in 216 is 6. 6 times 1 will give us 6. Plus 216 in 216 is 1. 1 times 5 will give us 5. If you add all them together, 144 plus 6 will give us 150. 150 plus 5 will give us 155 divided by 216. If you like, you can decide to convert it to a decimal number, or you can decide to leave it. If you want to leave it in this form, make sure you put the base. The base is in base 10. If you like, you can put it in decimal, whereby you see 155 divided by 216. You see, the digits are too many, and you shouldn't have approximated. If you like, I can decide to put it in this form because of some. We have 71, 71, 76, base 10. Don't forget to put to 4 decimal places. Okay, to 4 decimal places because I have approximated. All right, let's go to the second example. Example 2. Example 2, number 2, where it has to convert 32.43 to base 10. All right, next thing is still the same method. We have 32.43 to base 5. So what will the power here be? 0, and this one will be 1, because this is what? Whole number. While this 43 is what? Decimal number. So this will be given, this will be given minus 1, while this will be given minus 2. Okay, as the numbers continues, then the powers will be reducing gradually. Okay, so now this will not be equals to, we start from 3. That will be 3 times, what is the base? Base 5, which is multiplied by 5. What is the power? 1. Plus, the next one is 2. That is 2 times, what is the base? Base 5. What is the power? 0. Okay? Plus, what's the next one? 4. That will be 4 times, what's the base? Base 5. And what is the power? Minus 1. Okay? Plus, next one is 3. That is 3 multiplied by, what is the base? Base 5. Okay? And what is the power? Minus 2. All right. Do you get it? Now let's continue. We'll open the bracket, and that will be 3 times 5. 3 times 5. Because 5 raised to power 1 will still be 5. Okay? Plus, anything raised to power 0 is what? Is 1. 1 times 2. That will be 2. Let me write it for 2 times 1. Because 5 raised to power 0 is 1. Okay? Plus 4 times, don't forget, if I remove this minus, it becomes 1 over 5. All right? Plus, let me manage this so that I can put my plus. 1 over 5 plus, okay? Then the last one is 3. We have 3 times. If I remove this minus, I have 1 over 5 raised to power 2. And 5 raised to power 2 is what? 25. Don't forget I said 5 raised to power minus 2. If you remove this minus, it becomes 1 over 5 raised to power 2. And 5 raised to power 2 is what? 25. Alright? Okay? So, let's continue. This will be equivalent to 3 times 5 is what? 15. 2 times 1 is what? 2 plus 4 times 1 over 5 will be 4 over 5 plus 3 times 1 over 25 will now be 3 over 25. Okay? So I can decide to add these two together. This is what? This is 17. I have 17 plus, this is 17 plus 4 over 5 plus 3 over 25. So I can decide to add all of them or find the LCM of all of them. So the LCM of all of them will still be 25. Okay? This will be divided by 1. 1 in 25 is 25. And 25 times 17, 25 times 17 will give us 425. So we have 4, 2, 5 plus 5 in 25 is 5. Is 5. 5 times 4 is 20. Okay? 25 in 25 is 1. 1 times 3 is 3. Automatically, this will be equivalent to 445 plus 3 will now give me 448 divided by 25. Okay, so this can actually be, this will now be equivalent to, if you like, you can decide to say 448 divided by 25 will give me 17.92 base 10. Or you can say 17 whole number. I'm coming. How many 25 can you see in 25? 25 times 17 will give us 425. Automatically, we have 17 whole number 23 over 25 base 10. And I'll leave it in decimal or I'll leave it in fraction. So this is how to convert decimal basis to base 10. If you want to convert decimal digits to base 10, this is how to convert them. Alright? If you find this class very helpful, kindly like my videos, subscribe to my channel. Alright? See you in my next video. Bye!